All right. Hi there, everybody. Thank you so much for attending a data architecture session at Tableau. Usually everyone goes to the desktop session, so I appreciate my fellow nerds being in here with me. We're going to have a lot of fun today. This is a brand new session I've been working on over the last year or so, some ideas that have been coming into me, different customers I've been working with, different scenarios I've been put in the field with. So this is a brand new session. We've never done this before. So your feedback at the end will be highly valuable. Let us know what you liked, let us know what you didn't like. Other than the presenter's attire, you should like just about everything. So really appreciate it. So you are in The Truth is in the Stars with Data Architectures for Tableau. If you wanted to be somewhere else, I won't be offended if you get up and leave. That's all right. So who is this clown that's talking to us? My name is David Spezia, and I've been with Tableau software for 6 years now, so quite a long time actually. I started when there was less than 300 people, and our conference had about 1,800, and now there's almost 14,000 people at this conference, including about 2,000 Tableau employees. So it's like overwhelming to see that over the last 6 years. I actually live and work in London. I've been living and working in London now for 4.5 years for the company, so a vast majority of my career has been spent living and working in London. I was an independent BI consultant for several years before that, mostly in the Cognos, Microsoft, and Hyperion stacks. I was the first person to international channel and OEM pre-sales at Tableau, get to work with a lot of our amazing partners. I really enjoy that time. And weird thing about me is I grew up on a pig farm. Yeah, true story, true story. All right. I'm going to repeat this session on Wednesday from 1:30 to 2:30. So if you just want to see it again, you know, come on in, or if you really liked it, tell your friends. The more the merrier. All right, except for Matthew, you're not allowed to say anything. All right. So what we're going to do is we're going to talk about how the Tableau interface talks to the database. To understand that is to understand Tableau, which is to understand why data architectures matter for Tableau. So there's some really core fundamentals we're going to go through. We're going to talk about where the data engine / the hyper engine fit in. We're going to understand how to best leverage our star schemas, our snowflake schemas, and how do we leverage our flat objects out there in the world. How do we set up data architectures for success, right? I'm actually gonna give you a bit of a template how to set up for success. And we'll look at different multiple tier approaches. I think this is very important as data sets get bigger and bigger and bigger. And we're actually gonna look at a couple of real world examples from the field where we took stuff, changed some architectures, and got performance improvement. So a lot of you are in here probably for performance, right? Probably performance and a little bit, how do I enable my data warehouse for self-service? It's going to be a blend of those two subjects, really, when we get down to it. So yeah, here's a fundamental question, right? What the hell is Tableau? What is this Tableau thing we purchased? At its core, it's a visual dynamic SQL generator, right? You drag and drop things around the shelves. That generates SQL, your database honors the SQL, and it turns that back into interactive pictures, which you then can interact with to generate yet more SQL, right? If you looked at the amount of SQL that Tableau generates on a daily basis, it can be gigabytes of text files. Gigabytes of text files. I've seen some customers go into terabytes of text files of all the queries that get ran at a very busy Tableau server environment. So Tableau is great at writing SQL. I think somehow it gets paid for writing SQL. And that's the magic, right? So as you are using Tableau desktop and you're interacting, right, what happens is you get a VizQL statement. That VizQL statement is an abstraction of what's on my canvas. Where are my pills? Are they on marks cards? Are they on row cards? Are they on these different shelves? Are they on the filter shelf, right? You get an abstract of where pills are. So it's a sentence-like statement. It reads pretty plain text. If you were to start digging through it, you would find it to be quite interesting. It's actually written into the log files as well, and we'll even go show you that in a little bit. Then we get an abstract query. So based on the position of all of these pills on shelves, we need to have a query eventually. But the first thing we're going to do is we're going to create a query abstract. And that query abstract is an XML-like statement that contains things like this is on the row shelf, this is on the filter shelf, here's some calculations. So here's all of the data I need to render this viz. Then we get the actual physical query. So there's two layers of abstraction before the actual physical query is written. And that physical query is in the natively executable syntax of the database you're connected to. right? So if you copy pasted out the syntax and put it into your management studio or into your IDE and hit execute, it will actually execute. It's pretty cool. And then it gets obviously sent down to the database. Tableau grabs it back and turns it into a picture that you further interact with. All right, so that's kind of a fundamental in how this thing works. And so when you lay that onto the Tableau interface, right, this is the Tableau interface. This is what you land to the very first time you look at Tableau. Most people start opening the Show Me pane and start trying to look for wizards. It's understandable, right? It's blank. It's a blank canvas. So you're encouraged to drag and drop things around. And what happens, right, is you get selects, right? Blue pills are dimensional selects and group bys. Green pills are aggregations. They're calculations that are sent into the query clause. So when you drag and drop blue and green pills around, right, on the row shelf, the column shelf, on any of the marks cards, you're creating calculations, you're creating group bys. And then there's the where clause. You drag and drop stuff on the pages shelf or onto the filter shelf, and you're going to be generating things into your where clause. Then, on top of that simplicity, there's a little bit more complexity, and that's the calculation layer. In Tableau, there's 4 different types of calculations. Most of you probably only know 3. There's actually a 4th. There's simple calculations like profit minus sales. There are table calculations. Okay, now that I've gotten my profit and sales back, do something in Tableau with them, right? So do it within the context of Tableau. There's a level of detail expressions, which generate nested SQL, and then there's also pass-through functions. You can actually write natively executable syntax, wrap it into expressions, and send that down to the database as well. And what we're going to do, instead of talking about it, right, this is great to have in theory, I'm actually going to show you a little bit on how this works. So cool, let's go ahead and show some product. I'll hit escape. I'm notorious about the new version of PowerPoint of just demoing locally and then that not doing anything. So I'm horrible about that. So if you catch me demoing and it's over on my slide deck still, just raise your hand, say, hey, pig boy, screens, and I will definitely address that. All right. So I've got a Tableau workbook open here already. I've done most of the stuff that I want to show you, right? I've got about 30 different tabs. So we're going to see quite a bit of product today. I think that's very important. And I've got this handy dandy little debug window. There's only going to be a few of you in the room that know how to get that, but those of you that know how to get that, it's a handy dandy thing. It's a handy dandy thing because I can do an interrupt. So I can tell Tableau, hey, don't run a query unless I tell you to run a query so I can see it. Right, I want to physically see my query. The first thing I'm going to do, so you make sure there's no tricks here at play, I'm going to refresh my data source connection. This is going to reestablish any connections down to the database and eliminate any caching that I have. So everything's going to run fresh, because if I were to click it now, you wouldn't see any query statements because everything's going to be hitting the cache. And it's important for you to see the actual query statements. Now what I'm going to do is open the debug menu, and I'm going to turn on, in the queries, prompt for each query. And now Tableau is going to do something kind of neat when I go to the first pane. When I go to the first pane, I dropped a green pill onto the rows shelf, and it wants to do something, right? It wants to do a select. So what you see is the SQL before it executes. Select sum sales with an as clause from table orders with no group by, right? If I go ahead and click no, oh, hey, you weren't supposed to do that. It executed the SQL statement. If I hit yes, it breaks it. We don't want to do that. And so what did Tableau do there? That's a great question. Well, I've got this handy dandy Tableau log viewer, which if you did want a copy of Tableau log viewer, the binaries are on GitHub. Just search GitHub Tableau, and you'll find this log viewer. And I'm going to grab the Tableau logs. So I'll go into Documents, My Tableau Repository, Logs, and we've got a date modified here, log.txt. I'm going to drop this in here, and I'm going to go ahead and do a quick scroll down. As I scroll down here, you'll see Tableau was doing a whole bunch of different stuff. And here you can see I've got an action that said, hey, I navigated to sheet 1. And after I navigated to sheet 1, it said, okay, let's go ahead and take a look at what's going on here in the worksheet. Right, so this is the VizQL statement here. It's pretty boring because there isn't a lot of stuff going on there, but you can see I've got Mark's color Uber effects, right? So it just dragged and dropped something onto one shelf. So that's the VizQL statement. Then from the VizQL statement, you can see I get a query that executes. And when I get the query done, I'll have a QP batch summary down here. This QP batch summary is a very interesting thing. This is where I have the query abstract. You can see this abstract here is very simple. You can see it's using aggregation and the data source itself, and then here's the output column, what it's calling. So when we ultimately look at this, it's a pretty simple abstract because it's a simple thing that we're running, but I also see down here the natively executable SQL, right? That was the SQL that was actually sent to the database right there. So these QP batch summaries are very, very informative to what Tableau is doing, right? So it's always cool to see that level of detail in the logs. I don't expect you to all go off and start looking at QP batch summaries, but maybe I'll spark a few of you to do this curiously. I typically find the performance recorder to be sufficient for most of what I'm working with, but I just wanted to show you those different syntaxes that we're working with here in Tableau. All right, let's keep going forward. So we talked about selecting and group bys. So if I go to my next viz here, you can see I've got a dimensional pill on product category on columns, and I've got a calculation to sum of sales on rows. So I got blue pills and green pills. And you can see the query statement here says, give me the select of the dimension plus the calculation down here, and then we can see it groups by that dimension. This is exactly what you would expect to happen for those of you that have studied SQL. All right, so I'm going to say no, don't fail this query. And now I'll go to the where clause, right? I'm putting state equals Florida on the where clause, so I drag and drop the state pill or the state field onto the filter shelf. It gave me a dialog. I hit the checkbox, give me Florida. And now we can see that Tableau has addressed the where clause of where state equals Florida. Right? It's a pretty efficient little SQL statement, especially if I had indexes on my state field. Yes, sir?
Quick question. When you're filtering, you just select the all. Does it execute a where clause?
If you select all on the filter shelf, you will not see anything on the where clause. It will ignore that. Great question. And yeah, you'd be able to test it out yourself too. All right, I'm gonna go ahead and hit no here, but that means, for those of you that understand SQL at a deeper level, people can do some silly things on the where clause, right? If you look at Tableau, typically when workbooks are not performant, the first thing I look at is the where clause. I'm always going to the filter shelf. I'm looking for funky looking date parts. If you look at Tableau SQL when we're using date parts, you'll see a whole lot of nested casts in things, so it's got to do a lot of execution on the database side, so just be wary of that. So one of the silliest things I saw in the field was this, and this is actually an example from the field that I saw, is they had a silly where clause. And you can see how much slower this is to execute because the where clause is this. When state equals Florida, then 1, else 0 equal to 1. That's going to do what's called a full table scan. It's going to require every single row to have this calculation fired off for it, and then it'll select all the ones. If I had 300 million rows, that's going to take like 3 or 4 minutes to execute unless they have some kind of cute column store index, right? So don't let your users do silly things like that. I have found that in the field. We were working on this workbook for like 20 minutes, and then finally I went, what's this? Oh, damn it. Yes, sir?
Why or how did you come up with that?
Good question. Why or how would that happen? So if I go in to what I dropped on the where clause here, I called something silly where. So I'll go ahead and quickly find that. I'll look for silly, and I'll go ahead and edit this. Oops, I didn't want to duplicate it. I had this great undo button. There we go. I'll go ahead and right-click, and I'll hit edit. So the user created this calculation, right? If state equals Florida, then 1, else 0, right? So the user created this calculation, which is a valid syntax calculation, and then they put that on the filter shelf, right? Because they just didn't know any better. They didn't know they could just put the list out there and then select the thing from the list, which is going to generate an in clause, which is going to be a hell of a lot faster than this thing. So yeah, Tableau was doing exactly what the user told it to do. It just happens to be really inefficient. So pay attention to your filter shelves, is what I would say, especially when there's date parts and things involved, because there's a whole lot of nested casting that'll happen from time to time. We generate SQL. They don't always generate the best SQL, but we do generate SQL. So just be wary of that. All right, and now I want to get into different, yes, sir. The most efficient way to do that query is on the where clause piece here. Just drag the state out to the filter shelf, and as you drag state out to the filter shelf, it's going to be a list of the states. Select from list, and as you select from list, pick the values that you want, and it's going to generate an in clause, as opposed to this nasty calculation. All right, I got this thing in debug mode. It's getting a little finicky. I should be able to select from list without having to, oh, I broke the query, that's why. I have to use the negative. It was doing exactly what I told it to do. And then from here, right, if I just select none and then I grab like the top three and hit apply, you'll see it prompt up with the SQL again, and it's got an in clause here, which you know is going to be a lot faster. So that's the way to go, is use the lists that come out of these areas. Cool, great question. All right, so what does a simple calculation look like? Right, typically a simple calculation we're going to try to push to the data engine, or the database engine. And here you can see I had profit divided by sales, and so what I ended up with here is a quick little calculation dividing profit by sales down here. And I wrapped it in an if null, right? So down here I'm just doing profit divided by sales. So it's kind of exciting. If I had known, if I go into that calculation down here, this is the simple calculation, right? This is all I have in Tableau, profit divided by sales. So I'm pushing that in SQL down to the database to be executed, right? As expected. But there's several different ways to do this. There's also a Tablecalc. So hey, can I calculate this just in Tableau? Because I'm really just taking these two aggregate pieces and then doing the division. So when I run this, what you see is a more efficient SQL statement, because what I end up with down here is, hey, just give me the product category, the profit, and the sales, and Tableau's doing that division calculation locally, post-aggregate. Right? So it's pretty cool to see that we're not asking for things that we do not need. All right, we'll go ahead and not fail that query.
So are you saying then that it is more efficient for Tableau to do that calculation in Tableau than in SQL?
Correct, because if you saw what I had sent in the first equation, which was a bogus equation, it was a row-level calculation. So I said profit divided by sales at the row level. So it went in at the row level and did the division in the database for each row, right. Where here, I'm just doing the aggregate division. So I'm only looking at 3 different calculations as opposed to 8,400. So it's going to be more efficient on the compute cycles. That's not always the case, but in generality, it's typically faster to have Tableau do the local calculation unless you've got some kind of wonky show hide where you're doing a lot of calculations and just showing certain values. I can also accomplish the same thing with a level of detail expression. And as we saw in our interface diagram, that's going to do another nested SQL. So I'm going into my next tab, and as I go into my next tab, I can see, again, I've got a kind of a nested SQL down here where I'm doing that division. I'm passing that calculation down to the database, right? Level of details are great analytical expressions. They don't always perform the best. Right, so LOD expressions are great, but they don't always perform the best. That doesn't mean stay away from them because they're analytically very deep. Just be wary of them. All right, and I get the same profit ratio value. And the last thing I could do, maybe Tableau doesn't have a way to express the math that I want to use. Right, that's a common problem. I don't have a random number generator. There's a few other things that Tableau doesn't have. Right, I want to create my own UDF. In Tableau, how can I call that? Well, you can use a pass-through syntax to call a scalar value function from a database, or just, hey, execute this bit of SQL that I wrote because I'm clever, right? And so I have a pass-through calculation here on the last one that's going to pass through and do another nested SQL here. And you can see it's got a nested where clause here, calling from the same table, which is doing another select. And so it's a truly nested SQL. Just the one thing to be aware of if you're nesting SQL in this way, make sure you alias your table, or else you'll end up with some weird numbers. Yes, sir?
Is that a calculation
This is a calculated field. I'll go ahead and open that up and show it to you right now. So I've got this pass-through, and I'm connected live to SQL Server 2012, and you can see I had a calculation here called a raw SQL ag underscore real. And so from this, I put in natively executable SQL Server syntax, and then I did a little where clause, where equals %1. This %1 gets replaced by product category in the window on Tableau, right? So you can call some pretty crazy stuff from these pass-through functions. Like I can go out and call web services to pull back real-time stock quotes and things, just getting the data into the database layer, and this is how you do that. So you can do some really interesting extensions on Tableau with that SQL syntax. I used to always teach a course called Join Us at the Custom SQL Table, but they've kind of built so much functionality that I haven't had to do that recently. There's all kinds of ways to trick Tableau to do the things that you want it to do, right? That's what makes me a Sith Lord as opposed to a Jedi Master. I bend it to my will. Very good. Okay, so a lot of great Q&A. I really appreciate that. So shows you're actually interested in the data architecture class, so super happy about that. All right, so that comes down. Hey, Dave. Ooh, don't break the screen. Ooh, hey, what's mad? Okay. Is data architecture the magic bullet? I'm going to tell you no for the most part. When we look at problems in the field, typically it's workbook design, right? That wonky where clause I showed you, the way I was nesting SQL, which is a little bit more inefficient, right? If I just change the workbook design, I can get a more efficient SQL execution. If my calculations are a bit weird, if I can change my calculations, maybe I can use a Tablecalc instead of an LOD, or maybe I can do something in the database layer that will improve performance. Then, okay, am I writing kind of wonky queries? Then finally, okay, is it the data architecture? Right? Rarely is the data architecture the problem, but I will show some times when it was. So it's not the magic bullet, but it's something good to have in your back pocket. All right, so the next question is, hey Dave, where does the data engine from Tableau and Hyper fit in this grand scheme of things? Well, that's a great question. Extracts are a great piece of technology that Tableau does. It's one of the things I like the most about the tech is the extract technology. When your SQL execution is slow, you've got some smaller data set sizes, less than a few 100 million rows. You want to take your data on the plane with you, which I always like to do. You want to reduce your load in your data warehouse, or there's some type of persistence in the model, right? You want to materialize some calculations, you want to materialize some joins, some unions, some sort of weird federation or a calculation. Extracts can really help persist the execution into the data layer. It's pretty slick. If you've got some really nice MPP, you've got really large data sets, multi-billions of rows, you got real-time analytical problems or a really complex SSO or row-level security problem, you might always want to use the live engine, or the people that do it best use both. And I'll show you what that looks like a little bit later. And you can also optimize the data engine / Hyper. As you are selecting data, you can hide unused fields and aggregate, right? If I'm connecting to a big wide flat view with 1,000 different columns in it, but my user only created a workbook using 50 of those columns, why would I extract the extra 950 columns I do not need, right? Because I'm a data warehousing, right? I'm gonna break up a date into 50 different date parts. If I'm only using 3 of them, why bother bringing those in? Yes, sir. So the question is, okay, they showed us using billions of rows with Hyper compared to the data engine. I would say that Hyper can definitely handle a larger volume of data than the data engine. I did a lot of testing maybe 3-4 months ago that I sent to Alan, who was on stage doing that demo. And I was able to handle 4 billion rows with about 60 columns, and it was decent performance. Like every query ran in less than about 15 seconds, and that was 3 months ago on the build. So yeah, if the data engine usually kind of starts falling over at 250 million rows, we'd expect Hyper to start slowing down at 2.5 billion. It's an order of magnitude in improvement, but that's just some generalities. I'd say try it because it's included within Tableau before you start building aggregate objects and other things to support your analysis. Right? Sometimes it is the magic bullet. So the question might be, why is the data engine so fast? Well, it's essentially a hyper-normalized star schema. We take every single column and store it individually within the extract file itself, and it boils each column down to its unique name value pairs. So if David appears 15 times in the database, there's only one entry in the Tableau data extract, and it also runs in memory. It has really, really high ends of compression, and it's left compressed in memory. And queries are ran with the context that you run them, especially on the where clause, and it has persistence of those complex things like joins, unions, and calculations. So the data engine and hyper engine are really great for speeding up particular analytical use cases, a single viz, a single dashboard. They're phenomenal at that, especially when you hide unused fields and aggregate to just what you need to render that viz. You can really get things rendering hyper fast. All right, another question might be, hey Dave, what about the data server? This might be a little bit controversial, but that's okay. If you want to use the data server, it's great for doing a shared meta model. If you're looking for performance, do not look there. If you have something that's not performant, putting it in the data server will make it even more not performant. It's going to get better in the future. We have an active task force up at improving that. And the question might be, well, why, Dave? Why is this breaking? Well, the communication process complicates things a bit. So earlier we saw this diagram here about how we chatter down to the database. What happens with the data server is we remove that abstract to physical query link. We create a secondary abstract query called a SQL proxy statement. That SQL proxy statement is a very verbose abstract, very verbose. I've seen 3 lines of SQL be 15 pages of SQL proxy, right? And so it's very verbose, and it goes to the data server to be interpreted finally into the physical query. So we've introduced another step. Hey, we're gonna go ahead and speak Chinese so we can speak Japanese down to the server that speaks English, right? When you do that many translations, things get lost. Some optimizations we do with, join culling and things kind of get lost. So just be aware of that complication. It will get better in the future as we continue to invest in the technology. All right, okay, Dave. I've got some denormalized and flat file objects my users have. They got some CSV files, they got some JSON, they're pretty clever, they get their hands on data. What do I do with these, right? That might be your next question. One simple answer, the data engine or Hyper, depending on what version you're gonna be using. Right, for JSON, statistical files like your X7 BDATs, your CSVs, your text, your Excel, your XLSX, your AccessDBs, your web data connectors, and other file-based data sources, use the data engine. It's going to put a lot of compression on those things and allow them to execute very, very quickly. And there's other architectural reasons why you'd want to do that, but I don't want to deep dive that right now because of time. Yes? So if I connect to Excel or CSV, isn't there a shadow extract created kind of dynamically? Yes and no. I don't want to get into the semantics of that, but it's typically best to deliberately extract it. And then you can schedule it, and then you know it's extracted for sure. And it's going to scale a lot better as you get multiple hundreds of people connecting to that. Yes? Hyper will be the default data engine in Tableau with 10.5, yes. So instead of a .tde file, you'll have a .hyper file. And instead of TDE server 64.exe doing the execution of queries, you'll see hyper.exe doing the execution of SQL queries. There is nothing they need to do extra. It will just Hyper can execute TDEs, and then the newest ones as they get saved, as things are updated, will be saved into .hyper. So it'll be a very seamless upgrade. And I can say that from experience because I can open .tdes in Hyper already, right? So it works. If you have a generic ODBC connection, lots of custom SQL, or things like a Hive connection, or other NoSQL databases that are really optimized for analytical query, Data Engine's a great way, Hyper's a great way to use those. Overworked data warehouses, using the data extracts and Hyper is fantastic. And again, persistence of analytically complex things like joins, federation, unions, and calculations. All right, so enough talk about all this stuff. Yes?
In terms of the extract optimize, so of course it materializes the columns, but is there a lot of other things
So if I'm connecting to a database and I'm building stuff out, and then I hit extract, and then I add additional columns later, when I hit optimize, those additional columns I add past the extract, that's what gets optimized into the data extract. Yeah, but if I publish it to server and I have it on a refresh schedule, the refresh will automatically optimize.
But if there's something else on top of this materialization,
No.
so everything else is incorrect.
Yeah, it doesn't do anything else. Yeah. All right, so let's go ahead and demo some of this fun stuff. All right, I want to make sure I'm conscious of time here. All right, we're about halfway through. Very good. All right, so we're going to switch over to another demo here, and we'll go back to good old Tableau, and we've got some live SQL, and then we're going to have some TDE SQL. If I go to start here, yeah, I don't want to force that to fail. I'm going to not force that to fail. Nope. Okay. So first thing I want to do is turn off that, hey, here's all my queries being executed into my engine. So I want to turn off the debug mode. That'll be the first thing I do. And I'm going to go ahead and turn on the performance recording. Go ahead and start performance recording. And now I'm going to refresh this so we know where I'm not, just kind of using smoke and mirrors. I'm refreshing that. And now if we go to the live SQL viz, as I go to this live SQL viz, I'm actually connected to about, it hit the cache. That's a bunch of poop. Oh, well. And if I go to the TDE viz, right, you can see how fast these things render. I'll go ahead and stop the performance recording. I don't think we're going to get anything back from that because it didn't clear the cache like I wanted it to. Oh, well. Now we'll get back our performance recording. Go ahead and switch this over to zeros. Bingo. All right, so now we can see executing the query. When we were connected to SQL Live, it took 3.29 seconds to execute my SQL statement. And when I was connected to the TDE worksheet, it was 0.37 seconds. So pretty cool to see how much faster the TDE was in this case on 5 million records. It was an order of magnitude faster. It's just the context-sensitive engine of the query, the in-memory, and the compression allows us to get some pretty crazy performance improvements. All right, it wasn't everything I wanted to show there, but that's all right. We've got time on our side. All right. Go back over to the PowerPoint here, and we'll go ahead and continue on. All right, so Dave, great. I'm happy that I can speed up things that are not fast. I'm glad I can persist in things. I'm glad I can take my flat objects my users have and make them performant. But I've got star schemas and snowflakes because we have Kimball star love. Okay, great. What do you do with these? Simple. Live connections with multiple tables in Tableau, especially when your stars adhere to referential integrity. Because Tableau will do some cool things when referential integrity is turned on in our database, if it exists. Are you using an MPP or a column store? Denormalize the star schema, and then use indexes to expose that cleverly out to your user base. MPPs are really great, but they're not really great at joins. Flatten the thing out, materialize it, and build a correct indexing strategy. We'll see what that looks like here in a little bit as well as we continue forward. All right, let's go ahead and demo some of this stuff. Back to the old Tableau. All right. So the first thing I'm going to do is refresh all of my O3 data sources. So I'm going to tell it, hey, let's do it this way. We're going to go into data. We're going to do it this way. Refresh, refresh. So we'll go ahead and make sure we're not hitting any caches. Okay, that doesn't need to be refreshed. Good. All right, now we'll go turn the query catcher on again, prompt for each query. And now, when there's no referential integrity here, and we run a query, so I've got a simple join model here. All right, my connection wasn't up and valid, that's fine. Let it do the metadata queries. You're gonna watch me hit no a bunch of times, and now we'll get back to some number of records here. And you can see it's giving me a select sum one, and all of the joins are there in this SQL clause. So all the joins are in here, right? Just to pull back the number of records from the fact table. That's pretty inefficient executing all those joins. I'll go ahead and hit no. It'll go ahead and execute that query. Good time to drink some water. So this is executing a query against Cloudera Impala with a Parquet file format. So it's not exactly a non-analytical type store. It's on a 6-server cluster, and it's got about 617 million rows in my fact table. Pretty cool. If I go ahead and edit this real quick, edit the data source, you'll see how it joins together. A nice simple star join together. There you go. Nice simple star, all inner joins, cleverly designed. Go back to my no RI, and you can see when I right-click on a data source, there's an additional option down here called Assume Referential Integrity. If that is turned on, the query will look like this. You're gonna see me do a whole bunch of meta queries now. That's why I couldn't refresh those, they weren't connected. I reopened the workbook too many times. That's okay. Don't worry about those. Now it's going to execute the actual query here. So I'm going to get back an actual query. That's a much more efficient SQL statement, right? Just doing select from the fact table. I'll go ahead and hit no, don't break. And when this executes, instead of taking, upwards of 25 seconds, it takes about 2, right? Substantially different improvement on that assumed referential integrity. It's really handy when you got people putting a lot of quick filters and things out there on Tableau, because Tableau is going to write queries to populate each one of those containers. So referential integrity will really help us just query the dimensions and not do all the joins. So that's very important. That is a bit of a magic bullet button when you're connected in this live connection mode with multiple tables. That will write far better SQL. And you can even join the tables together. So I'll go ahead and hit no here. So here I've got a star with referential integrity, and I'm going to build a pretty complex viz. So I've got my referential integrity, I've got my good Kimball star, and I'm asking the database engine, in this case Cloudera Impala, render back this view. And it's a rather complex view, and it's taking quite a while for this to come back from Cloudera. Even though I've done all these other things in Tableau to make sure my SQL was good. We can see it's taking a bit of time. Should take about 45 seconds, so bear with it here shortly. It should get a viz. Oh, second pass SQL for the sort. Now it's computing the view layout. So that was pretty complex. Now we'll get a quick bubble map. It's going to take about a grand total of about 60 seconds to render that one viz. Right? I'd made this deliberately complex. So what could I do? Well, I have another option. In this database engine, I have materialized the view into another table with a Parquet format. So I have all the joins materialized together. I could have also chosen to do that with a Tableau data extract, but having a 617 million row Tableau data extract that is a direct representation of 250 gigabytes of Cloudera data, it might not be a good idea. That's why I bought Cloudera. What can I do? Well, I'll materialize this view and make it flat inside of my Impala plus Parquet. So when this executes, right, instead of taking 60 seconds, it should run much, much faster. Let's see here. 15, 16, well, I think much was an exaggeration. It should run faster. 3x, right? That was 20 seconds instead of 60. Now it's doing the second pass. So instead of taking almost 45, 50 seconds for the first query, it now takes about 20 seconds for the first query, and then there's my viz. So I've materialized the joins. I've pushed things together. I could make it even faster if I had it aggregated behind the scenes as well. So always good to see us getting performance improvements by changing our data architectures. All right. Back to good old PowerPoint.
Are there like some rules that, or some guiding principles that can be used to determine when do we start materializing stuff? When you have cross-fact joins, for example?
We'll show an approach here. So we're getting right into that point. So I'm driving all the questions, so hopefully it addresses it. If not, just let me know. All right, so I always like to look at things within the human scale of data. I think this is very important, right? If you're sitting down to analyze 3 billion transactions, you're gonna have to put things in consumable chunks. or else you're not going to be able to analyze that data. And I think every data has this logical type of hierarchy, where I've got my stuff up there in the weeds, or my stuff up there in the clouds, where my executives live, all the way down to the stuff that's in the weeds, where my data scientists live. And all data can be broken up into these hierarchies, whether it's a time hierarchy of year, quarter, month, week, day, hour, minute, second, millisecond, right? Or region, country, state, county, zip code, or product hierarchies through departments, or personnel hierarchies through a company, right? Data's always got some natural hierarchy to it. And you can always start at the top of the hierarchy, make some decisions, and then drill down. And you can use materialized aggregates in the data engine or in the back end of your system to increase the performance of some of these queries at the top. And then you can leave your low-level data sitting in your data engine, database engine of choice, and drill down to the raw data, grab context. So as I'm interacting with the data, I filter a year, I then filter a month, I then filter a week, I then filter a single day. Okay, that wasn't what I wanted, so I move up a couple of tiers. I move over to the different dimension that I want, and then I drill down. So most data ends up in this type of flow, depending on where you're at in the hierarchy. Do I want to look at all my different regions, then the districts, then the individual chains or stores or individual salespeople, right? You can always have this type of hierarchy in your data. All right, there's another clever trick that I saw on the field. One of my customers I work with out in Sweden, they've got a 17 billion row fact table in their transactions. And they usually only look at a week worth of data from the previous week and the previous week last year. That's what their analysts typically care about when they want to do something ad hoc. There was some kind of weird blip in the week. Let's try to explain it to executives. Okay, there was a really cool blip in the week. What did we do right? And so what he's done is he's used parameters in Tableau to set a week on the where clause here. Okay, between this and this. So instead of looking at 17 billion transactions, he's now looking at a few 100 million, a few tens of millions, and he's using that parameter date start, parameter date end on a column that's been indexed in date. And so we can get back some pretty neat, fast performance that way as well. All right. Yes? Yep. Yeah, this is going to be a lot more direct comparison here. It's not executing a formula. This is an actual input static value that I'm putting in with a parameter in the Tableau UI. So I'm putting a date start and a date end. So I'm giving it a very explicit range, and those dates here have been indexed. So it's going to be much, much faster. Much, much faster. All right. So some examples from the field. I think it's always best to define a data strategy, right? Let's sit down. When should we go use something else technology-wise? When should we look at aggregating, et cetera? So we need to define our data strategy. And as we do that, you know, there are different source systems, ETL into our EDW or ADW, right? Enterprise Data Warehouse or Analytics Data Warehouse. We've got fact tables that we then turn into views. There might be some aggregates and functionality we turn off of those views. And then we've got our user with Tableau desktop. Well, how do they connect? Well, typically, if we've got a wide flat view, let's go ahead and do a live connection to that live wide flat view. And if it's fast enough, we're fine. But if there are things that they want to repeatedly ask, or it's not within a time window that's sufficient, we can use a Tableau data extract to be our analytical query cache, essentially, or we can speed up a slow viz, and we can still drill down to the live connection if we want to go into a deeper level of analysis. And if some of the stuff I'm doing in the data engine is pretty useful, and there's some really cool new logic that my business users are coming up with that might want to be core logic, right? I might actually want to move that logic from the user tier forward. And me as an admin, as I'm looking at workbooks on the server, it's typically best to have some sort of performance benchmark viz that will look at all of the vizes and how long do they take to execute. So I can proactively go, hey, you know, Sami, your viz runs in 60 seconds, everyone else's runs in 15 seconds. Can we help you? Are you not using the data engine? Are you not using some of these aggregated materialized views that we've built in our Agile Data Warehouse for you? So you can monitor the activity on the Tableau server with some sort of performance benchmark. You can use The LogShark has the performance benchmarks on it, custom admin views. So monitor that and proactively reach out to your user base and say, hey, are you using our strategy? Because you're probably not if your vizzes are running that slowly. And we can always get some useful insight that we end up migrating through as well. And a lot of data can look like this, where I've got a workbook. And in that workbook, I want to use the guided approach. And I've got a wide flat view, which has A level, B level, and C levels of cardinality, so low and high cardinality fields. And my user on the desktop, as they're leveraging that, they might build a dashboard by a lower cardinality field, and then another dashboard by a slightly higher cardinality field, and then finally a dashboard by a low level of cardinality, or a very high cardinality field, like an individual salesperson or a store or something. And we can send action filters in Tableau from dashboard to dashboard to dashboard to get that context pushed into the next tier. And then we can have an aggregated object for the A tier, an aggregated object from the B tier. And because we used that SQL table, maybe the last one, that most granular one, we just want to go ahead and push a live query in as opposed to replicating all of my data. And because they were all sourced from the same source, we can actually ensure there's integrity from A to B to C. Right, so this is a very common strategy with multiple billions of records. We'll break it up so it's humanly consumable. We'll push aggregates into the data engine or possibly into the database itself with some materialization strategies on the column store indexing. And sometimes we can just change the data architecture. So if I give you a retail example from EMEA here, where we started off with this, and we went to something that looks like this, we've got a huge amount of performance improvements. So I'll go ahead and look at that real quick. All right. And I'll use just that one example, and there's some other stuff I want to show you. So we're going to go back to where we were, which is data architecture in the stars, and we're going to go ahead and look at the retail example, and we're going to go ahead and open the first example. And this is using 55 million records, about 3.3 gigabytes worth of data. So it's not child's play, right? It's a decent data set. All right. And so my workbook will come up, and as my workbook comes up, I'm going to wait. I'm going to wait some more, and then I'm going to wait some more. I'm going to take a drink of water. I'm going to execute some queries. Actually, end up executing 96 queries. I'm waiting some more. It's a pretty horrible experience. I'm not enjoying myself. I think Tableau is slow, when Tableau, in fact, is not slow. Okay, now I want to go ahead and make a change. Let's go ahead and make a change. Go ahead and do a quick little selection, and I'm waiting again, right? So I have this big, wide, flat representation of Tableau. It's just not sending optimized queries to my back end. Well, if I go ahead and make a couple of quick changes, so I'll go ahead and make some quick changes here. I'm going to open another Tableau here real quick. Cancel on that. That's okay. Come back over here. And now, whoa, that opened a lot faster. Right, now I can go ahead and check the chunk. Let's go ahead and grab a chunk of data. Okay, let's go grab another chunk of data here. So I grab another chunk of data. Let's grab the last chunk of data. And now, okay, I'm curious about this. Bam, here's my detail. So I've got two extracts here, one that pushes the first set of charts, one that pushes the last set of charts. It's the same data. You can see how incredibly much faster it is. Right, we'll do that again so you know it's not trick. Yeah, go to cosmetics. So inside of cosmetics, we've got this group here. Instead of that, we got our prestige brand. Instead of that, we've got our Forneo brand, and now we can go into this area as well. Right, so you can get a lot more speed by pushing data into a design that humans can consume. That's also very important. All right, so the last thing I want to do is the same query 4 different ways. I'm not going to do it the first way first, because the first way is just brutally slow. I don't want to have to sit here having you make me watch a spinner. So I'm going to go ahead and open this bad boy up one more time. So I had closed it down. Something went off into La La Land here. And so I'll show you this in 2 or 3 different ways. I've got a 10 million row table in SQL Server with no indexing. I don't want to do that. I've got a 10 million row table with regular indexing one with column store indexing, and then finally a Tableau data extract, all with the exact same data. And so if I come over here and I open this flattened view, no indexing, just rendering the first chart alone takes some time. Yes, sir? So yeah, the fastest SQL statement is no SQL statement. So I like to use this type of guided analytics. If you want to learn more about this, there is like the Tableau performance white paper, or designing for performance. It goes into this theory quite deeply. Right now, if I go ahead and make a selection like dried fruit, no indexing, no good data strategy, I'm just waiting forever for this thing to execute. I'm actually gonna hit cancel because it'll take about 70 seconds, and I'm not gonna bother with that. If I do the exact same viz, flatten view with a regular index, it'll go ahead and render that first chart quickly enough. Better, not great. I go ahead and pick a selection here. I do have an index on tax 1, tax 2. I have an index on supplier. That was a much better experience than before. And now I want line item details. Okay, select this supplier, and then we'll populate this list down below. Bam, that's a much better experience. If I walk through the first one in entirety, it takes about 2 minutes, right? Okay, now let's use a column store indexing strategy. So now I'm gonna use SQL Server data warehousing with a column store index, then I'll go ahead and execute these queries. That should be a lot faster. I'm not sure what's going on. That should have been about a half a second. And now I'm gonna go ahead and pick dried fruit, right? You can see how substantially faster the column store indexing is. The column store indexing, co-locating my index together, really adds performance in certain analytical queries. So I like that column store indexing. And then finally, if I go into a data extract, which is a hyper-normalized column store, right, and I click, right, it's all the same 10 million records, Tableau wins. So very cool.
So how did you set up the relationship between those three data sources? Are they joined on IDs, or are they blended?
It's a big flat object. So I have a flattened materialized view. So I've actually joined everything together, and I've stored that flat object. So the relationships are all through the row level stuff. I haven't actually built different tables or anything. So it's a big, wide, flat thing. Because my users understand big, wide, flat things that look like a spreadsheet so easily.
Those records one-to-many, for example, joined together?
Yeah, they're mostly one-to-many.
So how do you handle the aggregation? Is it just handle both that? We have problems, we have to do level of detail for one-to-many relationship data sets, because it will inflate the data.
Let's talk about that later. We'll talk about that later. Just come see me after, and we'll drill into that.
You mentioned this big flat white denormalized sets. Is that the third option? So we have a fact table with a handful of dimensions. Would you always recommend that we flatten it up before we treat it Tableau?
Your end users are gonna wanna consume it as a flat object. So build the joins together so it looks like a flat object, or just make it a view in your database.
So game plan that we are thinking to create a workbook which already does the joins
Yes,
and gives that. So that's effectively flat.
yes.
But what I was asking is that you don't need to necessarily build a view on the side of Tableau.
You don't, unless you're gonna start applying the multiple aggregation strategy. Then it's nice to have the one big flat view, so that's the parent of all of the children of aggregates. That's when it can be quite handy. So, good questions. All right, let's go ahead and wrap this thing up. We got about 3 minutes left, and then we can do some more open Q&A, or you can just come see me afterwards for the one-to-many stuff. Just come see me there. So, in conclusion, right? Always consider the design before the data architecture. Break it up, right? Remember that human scale of data. Use persistence and materialized views to answer our common problems. So if I'm always asking the same question over and over and over again within a narrow slice of 20 columns, materialize that thing and aggregate it. You're gonna get a lot better performance, right? Use wide flat objects so your users can understand the data. Looks like a giant spreadsheet, right? Then use the TDE or a column store index with an MPP for document level or query level acceleration. And then finally, action filters are amazing. I've got a lot more content that I'll typically do on action filters, but action filters can jump across platforms. I can go from data engine to SQL Server to Cloudera to text file. It doesn't matter. As long as I've got common dimensions, I can use the action filters in Tableau to jump through all of those things. They're really amazing. All right. So I would highly encourage you to take the session survey. This is a brand new session. Worked really hard to hopefully put some knowledge in there for you. If you liked it, great, give me some thumbs up. If you didn't like it, let us know what you didn't like, what you wanted to see more of or less of. I really want to make sure this session is good for you. So any other questions? Yes, sir.
Using the option to assume referential integrity, you mentioned something about filtering strategies. How does that affect dimension-driven application?
Yeah, so if I have assume referential integrity checked, and I've got 3 or 4 quick filter objects that I'm going to be using, Tableau is going to generate 4 queries. So 1 for each quick filter object, then 1 for the viz, just to populate them. If I use referential integrity, I can just query the dimensional table, which are always way, way less in membership than the fact table. And if I have to do all the joins to populate that, it's going to be a lot more expensive of a query. So referential integrity can really help speed up quick filter population. So that was that key point there. All right, well, we are up on time exactly. Thank you so much for attending a data architecture class. Thank you for all of your questions, and have an excellent conference.